Assalamu alaikum. This is chapter 5 uh, in the programming language course, in which we would like to shed lights on some concepts of programming languages, namely names, bindings, and scopes. The headlines of this chapter, as you can see, introduction, then the names, variables, concept of binding, scope, and the relationship between scope and lifetime. Also, the referencing environments in the programming language as general, and named constants. That constants that has names. So first, would like to define the some concepts like these variables in the context of imperative languages. Imperative language are abstraction of the known von Neumann architecture, which is based on memory and processor. So when they actually prepare a specific programming language, this programming language is designed based on von Neumann architecture, which is basically memory and processor. When we talk about variables, these variables has attributes. So when you'd like to design a variable, you must have a lot of understanding of the variable name, the variable type, the scope, the lifetime of this variable, how this variable is going to be initialized, and the compatibility of this variable, and type checking if we put it in a specific programming or scripting language, how this variable is going to be compatible with other code segments. Names, we'll talk about variable names. Variable has names, so variable has names. So there is some design issues for these names. We have to first find out if these names are case sensitive or not case sensitive. A name could be a specific name, like for example age, like this, or it could be age like this, or it could be age like that, or combination. So it is the same name, but case sensitivity here will decide the correctness of the usage of this variable in the language. So a design issue for names is case sensitivity. Also, are these variables special words or reserved words? For example, there is some variables that can be regarded as reserved words or keywords. Keywords have a special meaning in a language and are part of the syntax. And reserved words are words that cannot be used as identifiers, like you cannot use it as variable or functions or classes, because they are reserved by the language. In practice, most keywords are reserved words and vice versa. So the difference between these keywords and reserved words is very cumbersome. So all keywords are reserved words, but not all reserved words are keywords, although the difference is rather vague. So some language have directives which have a special meaning based on the context and can be used as identifiers on other places. In Java, for example, the word goto is a reserved word, but it is not a keyword, and so on. Also, names have lengths. Also, we have to find out if this name is too short, the name length, the length for this variables, are they too short? They cannot be annotative. Are they too long? For example, in C99 there is no limit, but only the first 63 are significant. That sometimes some variables have a length of 253, 54 or 55 characters. Also, external names are limited to maximum of 31 in C99. So when we talk about the first 63, we talk about the first 63 names of variables used in a program. C# and Java, there is no limit and all are significant. Or C++ also, there is no limit on the length of the variable. A variable could be very long or could be very short, could be one character. But sometimes implementers often impose that on the language and make specific conditions for using such lengths in the language. Also, special characters. Some scripting language like PHP or variable must begin with a $sign. In Perl as well, all variables begin with a special character like a $sign. But in Perl, for example, the beginning of the variable specifies the type of the variable. And in Ruby, for example, a variable name begin with this @ symbol. And sometimes the instance of variables and objects, they can also begin with @ as in class variables, for example. So special characters are used in programming language, but specifically in scripting language. In case sensitivity, there is the disadvantage, of course, in case sensitivity, because one of the disadvantages is readability. Readability is such that names that look alike are different. As I gave you the examples earlier, age written 3 different times with different spelling, I mean different case, capital, small, or first character is capital and the rest of the variable letters are small. So names look alike but they are different. This is affect the readability of the code. In C-based languages, names are case sensitive, like in C and C++. If you write a variable with a specific case, you have to follow that case. And in other languages, these variables are not, specifically in database programming languages. In C++ and Java and C#, because predefined names are mixed case, example like this example here, if you see that mixed case, the first character of the word is capital, like this, index, out of bound, exception. This is actually a keyword that is used in exception. Exception have names, built-in names, we call predefined names. Sometimes are very long, but they are mixed case. Also in PLSQL, sometimes you will find that case can be capital or small. But that is an example of a language that doesn't have case sensitivity problem, because you can actually have it in lowercase, uppercase, or mixed cases. But for the predefined names like this, they use mixed case in order to actually separate the words in the meaning of the exception, for example. Special words, they help in readability because they use to separate the statement clauses. like a keyword, for example. A keyword is a word that is especially used in certain context, and also reserved word, as we have given examples earlier. See, because it is a special word that cannot be used as a user-defined names. But there is some potential with these reserved words, because if there are too many of them, there might be some collisions. Collision means overlap. Like COBOL, for example, there's too many reserved words, like 300 of them in COBOL. So sometimes you will run out of names, and you would like to use some names of variables, and they happen to be actually keywords. So this is one of the problems that is can affect the usage of these keywords or reserved words. A variable is an abstraction of a memory cell. It's just a location where a value could be stored. And variable can be characterized by some attributes like names, address, value, type, lifetime, and scope. In the next slide, we're going to talk about these names, address, value, type, lifetime, and scope individually. Name, for example, some variables, they don't have specific names. Not all variables have these names. Some variables could be a location, like the what's called passing parameters by address, where you can actually point to the location of the variable where it exists. So it doesn't have a name, but it has a location. Or address, the memory address in which this variable are stored or associated. Because a variable might have different addresses at different times during execution. For example, you have been using some variables, and then you are using the same variable name in a different location for swapping reasons. So some variables have different addresses at different times at execution level. It depends on the code that you are writing and the length of the program that you are writing. So sometimes you have been using these variables in blocks, where each block is using its own variable as local variable. So the same name can be used in two different locations in the same program. A variable might have different addresses at different places in the program as well, as I just mentioned. So if two variables can be used to access the same memory location, they are called alias. So an alias is just another name for the variable, and they are created for pointers. They have been pointing to the same place or to the same name, so they're called alias. Alias in English means a name for the same thing, or a different name for the same thing. Aliases are harmful for readability, because if there are too many of them, program readers or designers or implementers must remember all of them, otherwise they can create some confusion to the designers or programmers. One of the variable attributes is a type. Type means data type. The data type determines the range of values of variables and the set of operations that can be used. What kind of operations? Math operation, relational operations, logical operation. In case, for example, of floating point types, also the type must be determining the range of values used, and also the precision, the decimal places of these floating points. Another attribute is the value of the variable. Value means the content of the location with which the variable is associated. What is the value? Is a value integer? Is it a floating point? Is it a character? Is it a string? What is sitting there in that location for this variable? That is a value. If I use L value, we are talking about address. The R value, we are talking about the value itself. And the abstract memory cell is the physical cell, is the physical location associated with that variable in the computer memory. We call it abstract memory cell, which is measured by bytes. Now we talk about the concept of binding. In the concept of binding, we have to define a binding. What is binding? Or variable binding. A binding is an association between an entity and attribute. Association, link, merge between entity and attribute, such as between a variable and its type. If you try to make association between a variable and its data type, or between a variable and its value, or between an operation and a symbol, operation like addition operation, and the symbol like plus sign, for example. Then we talk about what we call binding. So this is a concept of binding itself, which is an association between entity and attribute, as of these examples mentioned. The binding time, however, is a time at which a binding takes place. So at the time when this association between entity and attribute, whether it is between a variable and a type, or between a variable and its value, or between an operation and a symbol, such time during program processing is called binding time. So there is some possible binding times, like when the operator symbol associated to the operation, like a minus sign, a plus sign, or addition, or any one of these operations associated with these symbols that we are using in the program. So here we are talking about 5 different language time, like language design time, language implementation time, compile time, load time, and run time. So what is a language design time? A language design time is the bind operator symbols to operations during the design of the program. During the implementation of the program, we call it language implementation time, which is a binding such that it is association between a floating point type to the representation of that value in the program during implementation of the program. Compile time refers to the binding of a variable to a type or its value, for example, like in C or Java, when a program is compiled, during which process the variable will be checked to see what kind of a type is this variable that is used in the program. That's called the compile time. The load time, like binding a C or C++ static variable to a memory cell. Some variables are static, they don't change during program processing, but they are loaded once the program is loaded. In the runtime, we talk about the binding of a non-static local variables to a memory cell. So this is just the normal variable declared like in functions. So every, for example, small program segment or a function has its own local variables, and that is associated to a memory cell during runtime when you actually input the value from the keyboard or generate them from a file to test your program during runtime. So these values can be used, and during which we call that binding time, we call it runtime. I'd like to compare between static and dynamic binding. This is very important distinction. When a binding is static and when a binding is dynamic. A binding is static if it first occurs before run time, and remains unchanged throughout program processing. And if the binding is started before runtime and it doesn't change throughout the program execution, this is called static. But if it occurs during the execution and can change during execution of the program, this is called dynamic binding. So this distinction is important between dynamic binding or static binding. In type binding, we'll call about data type binding, for example. We have to worry about how is the type specified and when does the binding take place. At what time the binding take place? Does it take place at design time, run time, execution time, or implementation time? If it is static, the type may be specified by explicit or implicit declaration. We're going to talk about explicit and implicit declaration in a minute, because also defining or differentiating between explicit and implicit declaration, we talk about variable declaration here. When a variable is explicitly declared and when a variable is implicitly declared. For example, an explicit declaration is a program statement used for declaring the types of the variables. Generally, an implicit declaration is the default mechanism. So explicit, when you declare a variable with a data type like this, for example, int age or char letter, or for example double money, something like that. This is called explicit declaration. But implicit declaration is a default mechanism for specifying types of variables through default convention rather than declaration statement. So it is not a declaration statement, rather it is implicitly the variable will be given a type by default. For example, in JavaScript, the default value is default type is var. And in PHP, for example, we don't have a type, but we can use anything like. But if you start with a dollar and, for example, name, and then give it a name between quotation, or dollar number, and then give it a number without quotation, like 12, for example. So these are examples in PHP, for example, where there is no any name. There is no any type given to these variables. Rather, it is implicitly known that this one here is actually a string, and this one is actually a decimal. An integer. But if you put decimal like this one, for example, it will be automatically implicitly known as decimal. So these languages like BASIC and also like Perl, Ruby, JavaScript, and PHP, most of them are scripting language, but this one is programming language. They provide implicit declaration. There is some advantage and disadvantage, of course. Advantage is writability, because you don't have to intervene here to give any type. Disadvantage, reliability is not reliable, because people sometimes they need to know what type of data you need to enter from the keyboard, for example, or generate from a file. Before they do that, they need to know what type of data that they need. So it is not reliable, but it is writable. Some languages use type inferencing to determine the type of variables. Type is called inferencing with a context. That means like in C#, a variable can be declared with var and a value. If you look at this values also here, I would like to show you that in for inferencing, for example, if you declare var, this is data type which is in JavaScript, we can use also var value 1 equal a between single quotes. That means automatically, implicitly, it will be considered as a character. Var value 2 name between quotations, that means implicitly will be considered as a string. Var value 3 equal 10, that will be considered as an integer automatically. Look at the value, then look at the value. So from the right hand side, you will understand what type of data this variable is. If it is 12.36, for example, this is a double or float. So although they are given the same data type, but this one will inference or implicitly determine the type of the such value, such variable. Visual Basic 9.0 plus and modeling language, Haskell and F#, all of them use type inferencing like this. The context of the appearance of the variable determines type. That means the appearance of the value here determine what type it should be used. Some people and many of them define this static typing and dynamic typing with respect to the point at which the variables are checked, because this variable will be checked, for example, in some language at compile time. Like static type, for example, static type languages are those in which the variable type is done at compile time. But in dynamic type languages, the check of these types are done at runtime. So it depends on the type of the language. If it is statically typed, then the checking is at compile time. If it is dynamically typed, the checking is at runtime. Language like C and C++ and C#, we call them C-based languages, like and Java as well. These are all statically typed. Statically typed means the checking of the variable will be done at compile time. Language like Ruby, Python, and scripting. We talk about scripting here. Most of them are scripting. Ruby is a scripting language, Python is a scripting, and JavaScript as well. All of them are dynamically typed. So the checking of the data type is done at runtime. Dynamic type binding, like in JavaScript, Python, and Ruby, and all these languages, is very limited, and sometimes it is specified through some assignment statement, like in JavaScript, for example. So here in this array, for example, you'll find that this array is not of the same type. Some of them are integers, and one of them is double floating point. Using such kind of dynamic typing is flexible, but it actually have high cost in interpretation, and also it is prone to type error detection by compilers sometimes. And this type error detection by compilers sometimes can be very difficult to get or to receive through compilers. I would like to stop this video here and start the next part of this chapter from this slide.